there it is right there. Can you see inside there? There's a piece of something stuck in there. That is our problem. Can you see that? That little chunk right there is what was causing that thing to bypass. So that little piece on my finger is what was stuck. And you can actually see the mark right here where it's shiny on the seat. That piece was stuck there, allowing the gas to bypass inside the head pressure control valve. So it wasn't a failure of the valve, it was contaminants in the system.
This video is brought to you by Sporlan, quality, integrity, and tradition. Today we have a call on a walk-in cooler not working, and it's interesting because the fans are not running. Now, these fans run 24/7, so there's no reason for them to be off. The customer said they checked all the breakers. Let's hope it's not something this obvious. Nope, not that easy. Okay. So first and foremost, we need to start with the evaporative fan motors, see why they're not running. So we're going to open this guy up. Electrical should be in there, figure out the electrical issue, and then go from there. So this guy is electric defrost, so the fans are controlled from the roof. So we actually need to go up there. It looks like the limit switch been bypassed, but yeah, our issue is probably going to be on the roof because our power comes from the roof down to here. So I'm checking between 4 and N, and I have no power, so that should be my 208 volt power, so we do need to jump onto the roof. This satellite looks intimidating. What the heck? Beefy thing. I feel like I'm getting herpes just standing in front of it. Or curing me of it. I don't know. It's weird. Alright, my rack is right here. That's a good sign that all the fan motors are running. It's a little dirty. This is a little odd. Uh-oh. I don't like to see a tripped breaker. That's not good. That's not good at all. I need to figure out if that's my walk-in cooler. Let's see. Walk-in cooler system F, A, B, C, D, E, F. Oh no. Alright. I think this is my walk-in cooler. It's not a good sign that you see oil all right here. And it's also not a good sign that the compressor tag is completely melted off. Man, I hope we don't have a bad compressor. That's gonna suck. Alright, well, I'll open it up and get some gauges on it and test the system to ground. Alright, the first thing I'm gonna do, I turned off the breaker so there's no power. And I come over here and we're testing to ground, okay? So we're grounded out right here, and we've got no continuity to ground on that winding. Nothing on that one. Nothing on that one. So that's a good sign. Now we're going to check the windings themselves. Okay. That's interesting. 4 on one, 2 on another. Oh, you know why? Because this is a single phase. That's right. That makes sense. I was thinking this was a 3-phase for a minute. Yeah. So the compressor still has resistance, so that's a plus. It's definitely been overheating though. It's not hot right now. Looks like maybe there's a refrigerant leak, or there was a refrigerant leak. It looks pretty dried up. Okay, we're gonna open up this electrical box and see what's going on in there. So right off the bat, nothing's really jumping out at me in there. It looks okay. Okay. Looking at wiring, making sure nothing rubbed out. Where do we have a potential short here? I guess at this point, I mean, it's not really going to matter, but I'm going to put service gauges on it to see if we actually have pressure in the system too. All right, that is a plus. The system has refrigerant in it, so all right, we need to grab the meter and go tone out some other places and see if we can't find a direct short somewhere maybe that caused the breaker to trip. Okie dokie, so let's have a look at the contactor. I mean, it doesn't look amazing. but it doesn't look horrible. It's okay. It's not welded shut. Okay, here's my time clock right here. We currently have no voltage. I just checked that. So we're gonna have to test to ground to see where a potential short might be. Nothing on the N terminal. Nothing on the number 4 terminal. I'm checking to ground. Nothing on the number 3 terminal. And nothing on 1. Nothing is grounded. And it wasn't in a defrost when it tripped. Remember, this is electric defrost. So it was in cooling mode when it tripped. So what caused it to trip? Interesting. Huh. Well, we have power turned off, so we're going to test on the bottom side of that contactor to ground to see if there's a short in the wiring. Contactor to ground, no short. This is the load side of the contactor, no short, or no direct short to ground. Okay. So there's nothing wrong there. I don't see any issues in the electrical. Huh. It's a tricky one. So, what caused this guy to trip the breaker? Interesting. I'm not seeing anything in there. It could be a start capacitor, a run capacitor issue. We better test those. And then also we need to look into this wiring to make sure nothing happened in here. Don't see any issue there. We better test that crankcase heater too. So I'm gonna get in here and look around, see if I'm gonna pull this cover off too. Okay, the start capacitor is testing at 93 microfarads and it's supposed to be 88 to 108. So the start capacitor is fine. We need to test that run cap now. The run cap is testing good. It's supposed to be 35 microfarads and we're right at 35. So, okay. Testing the crankcase heater. It's not grounded out and it's got resistance across itself, so the crankcase heater is good. This is interesting. I don't know what caused this breaker to trip, and I'm kind of concerned. Huh. Alright, at this point, I've checked everything, and I think it's just time to turn on the breaker, but I'm going to leave the compressor disconnected. We're going to turn it on without the compressor, and then see where that gets us. Alright, yeah, because all the condenser fan motors are running. There's nothing else really tied into us, except for these relays. I don't know what those relays go to. Let's see if it says anything on here. System F. Yeah, R1. So those relays do go on there. Huh. Well, we're just going to turn it on and see what happens. Okay, power's on. Pulled in the contactor. Alright, let's go check to see if we have voltage at the compressor. Check voltage here. Alright, we have 200 volts between run and common, so that's good. But why did it trip the breaker is the question. We're really just going to have to wire it in. I want to go down and inspect the evaporator a little bit more before I connect this compressor back in, because I want to make sure we don't have any shorts and I don't want to damage anything in the compressor. Before I go down there, I'm going to click this into defrost. No trip yet. Let's see what we got here between. Three and N. .208, so we're sending defrost power.
still. We're sending nothing to the refrigeration circuit. Let's take it out. And let's check our refrigeration circuit. For an N. We've got 208 volts going down to the evaporator fan motors. Let's go downstairs and see what's going on down there. I'm intrigued to know why someone cut out the fan delay switch. So all the evaporator fan motors are running. Man, I hope it's not a bad compressor. I don't see anything going on up in here. It's like a needle in a haystack. This thing's kind of a mess, but I'm not seeing anything. I mean, nothing. Looks like it's shorted. Heaters don't look the greatest, but huh. Okay, well, I'm not seeing anything. We're gonna have to turn the compressor on and see what happens. All right, well, at this point, it's time to turn it on, see what happens. So we got to connect this compressor back in. Okay, we're going to turn it on and see what happens. Please don't be a bad compressor. It's running, but it's not moving refrigerant. What's going on here? Well, the compressor's not hot, but it's not pumping refrigerant. Nothing's happening. We're gonna turn it off. More than likely, we're gonna have a bad compressor. That stinks. Okay, we're off. I'm trying to think in my head right now. There's nothing that could be causing these pressures to do this. We're hooked onto the suction side. We're hooked onto the discharge side. We should have compression and we don't. It's like the motor's just moving. Try it again. It's on. No pressure change. And we're pulling current, so the motor's moving, but it's not moving the scrolls. Something's happened inside. That sucks. All right, I got my new compressor. It's a little guy. What I was able to do was front seat these valves, recover the charge in the compressor, and I'm only gonna have to, if all goes well, unsweat these and sweat the new compressor in. That's the plan. Let's hope that everything matches up the way that it's supposed to. But it looks like it'll work. So I'm gonna get in here and sand up these braze joints, unsweat them, and then pull the compressor out of the way and go from there. We've got some new starting components, new Molex plug, so try to get it dialed in. Once we get the compressor replaced, we'll vacuum it down, start it up, and then we'll pump the system down and change the dryer. What I get for trying to rush through things. I had a casualty of war here. Pressure control, the low side. came off of there because I didn't take it off when I was trying to unsweat it. But I think I have one of those in my van, hopefully. But anyways, I'm gonna keep going with the compressor change out. Got the compressor sweat in, just 2 simple guys. It went right in, that's perfect. I still got to figure out the bolts and stuff, but I'm gonna get that pressure control hose replaced and the vacuum pump running on this guy, so that way we can start it up right quick. And I still got to change the starting components too, so I'm gonna run down to the truck and see what I got. All right, well, yeah, I kind of screwed myself. I don't have one of these hoses, so I'm gonna have to do it with 2 flare nuts and some 1/4-inch copper. We're gonna make a little chingus and connect it to that. All right, it is not pretty, but it'll work for the night. Nice in there, so I'm gonna get the vacuum pump running on it, and then hopefully we can start this guy up. All right, because I'm just evacuating the shell of the compressor, there's no need to go crazy with my vacuum setup. The 1/4-inch hoses will be fine. It'll take a few minutes, but I gotta put the starting components in anyways and do the crankcase heater. So we got plenty of time. We'll just let it run. It'll get down into the micron levels here in just a minute. Pull the vacuum, opened up the valves, we're good to go. We got pressure both sides. We're ready to start this guy up. Everything's wired in here. Crankcase heater's wired in. This guy's ready to go. And hope that everything goes well.
Crank it. And it's running. So we're gonna let it operate. Let it run for a few minutes. See if we can bring the box temp down. Then we'll change the dryer. I may even change the dryer in the morning. We'll have to see. I'm gonna let it run for a few minutes and see what happens. I don't want to shut it off quite yet. Hot discharge, cool-ish suction. It's gonna be a while. I'm gonna try to clean up some of my messes and let it run for a little bit. So, all right, we have been running for a few minutes. We've got a cool, cold suction line coming back, and I noticed that my head pressure is really high. It's probably only 80 degrees out here. It shouldn't be this high. So I come over here to my head pressure control valve, and it's bypassing, it's stuck. So I have a really hot line coming out of the head pressure control valve, and then the liquid drain coming out of the condenser is a lot cooler than this line. So this thing is bypassing hot gas through, and that's probably what added to the compressor failure. It's probably been running like that for a long time. And remember, the old compressor had a burnt sticker on it. So what I'm gonna try to do is I'm gonna try to go ahead and put a sprinkler on the condenser for tonight. I have a head pressure control valve at the shop. I just don't have one with me tonight. And I would have to recover the charge. So if I can get a sprinkler on it for tonight to get it to make it through the night and keep the head pressure, I could be here first thing in the morning. We'll change this guy, we'll recover the charge, we'll make it look nice, and put a new head pressure control valve on there. So I think that's what we're gonna have to do just to get us through the night. We're gonna go downstairs and make sure it's getting cold, and I'll clean up my messes and then get a mister on the condenser temporarily. What I did, we gotta make sure the sight glass stays clear though, is the problem. Hopefully it has enough refrigerant. So my head pressure is dropping. Got to give it a minute because the sight glass is still flashing and I don't like it. But it could just be because it's opening all the way. It's interesting because it's still bypassing, but it's gotten a lot better. I actually turned off the mister and just forced on all the condenser fan motors, and that's a reasonable head pressure. I'm gonna let it run for a few minutes and make sure it doesn't get too high. But the sight glass is clear. Super cold suction line coming back. The temperature in the box was like 42 a few minutes ago. So we're gonna let it run for a few more minutes, just make sure there's no other issues. All right, we are back this morning. Got my whole van on the roof. We got to recover the charge, got a bucket full of ice. So we're going to get ready to change that head pressure control valve. What I have here, let me close this off, is I went ahead and put my service gauges on there. We went ahead and opened the packings, or loosened the packings on these guys, so important, okay? Actuated the valves, and you can see my system pressure. It's not too bad, you know, nothing too alarming. I'd say it's about 80 degrees outside right now, but we still have the same problem. We have discharge refrigerant coming out of the compressor, going up that line into the condenser, coming out of the condenser on that 3/8 line. But the problem is that this right here going into my receiver is hotter than the 3/8 line coming out of the condenser, which means that this head pressure control valve right here is partially bypassing. And it should not be, because the bypass pressure on that guy is about 180 PSI, and we're at 272 PSI. That should be shut, all right? This discharge, or this line right here, should not be hotter than the liquid line during normal operation, or the liquid drain coming out of the condenser. So that's more than likely what killed this compressor. Now, I got it operational last night by manually making all the condenser fan motors run, and by putting a mister on the condenser right here. Just to get them through the night, we're gonna turn that off, we're gonna recover the refrigerant, change the valve, and hopefully be done with this guy. We're gonna see, I turned off the misting device, and my head pressure is slowly climbing now, and it's gonna continue to climb. You know, last night it was about the same temperature as it is right now, and we were at like 320 PSI or something, which was too high for the temperature. You can see right now it's about 87 degrees, so, but it's slowly gonna climb more and more until it becomes a problem. So at this point, we're gonna go ahead and shut this guy off. We're gonna go ahead and recover the charge out of the system, and then go from there.
I'm trying to take a shortcut, and so what I did was I put my high side on the receiver port and I pumped it down. But it's interesting, this is one of those where the receiver port loses pressure when you pump it down. So there's still high side pressure in there. What I'm inevitably trying to do is I'm going to recover the charge out of the high side, but as it gets really low, I'm actually going to shut it off and close, front seat these valves. Well, that's the plan, so that way we don't have to evacuate on the compressor oil later, and that we're just evacuating on the system. But I'll have to see if I can make that happen or not because of the weird setup they have. We've got our tank and ice water carefully on the scale, large diameter hoses, everything's set up. We purged it. It's basically ready to open up. We're gonna start filling with refrigerant. We'll pull from both sides. We'll go ahead and hit start. Now, the ice water is there to reduce the tank pressure because it's warmer outside. And the tank pressure will come up to the point that it'll trip the head pressure control. Everything helps with this. The ice water, the large diameter hoses, no Schraders, all of that helps to speed up the process. Now, the maximum amount of refrigerant, R404A, that we can put in here is just a little over 17 pounds. So we're weighing it as we're pulling it out, that way we don't overfill the cylinder. So we've done everything we can. We sanded up the head pressure control valve, we unbolted it. We're just about done recovering. We're on the tail end of being overfilled on the cylinder, but when I calculated it, I put the maximum temperature of 130 degree tank temperature. That's if I was to store it in my van. As you decrease the temperature, the storage capacity goes up. We are gonna just be reusing this refrigerant, so it's not 130 degrees right now. It's just about 80 degrees. So if you take 167 PSI, that's the outlet pressure, that's the pressure in the tank. 404, it's gonna be right around 80-ish degrees. So we're good right now, but that's why it's so important that we cooled this guy down. On hotter days, that temperature gets super high and it creates a problem. But look at, we're just in the negative and we're right at 18 pounds. So we're gonna go ahead and shut this guy off and get changing on that valve. All right, we are purging with nitrogen right there. I do have to unsweat the valve, so we're gonna do that real quick and then move on. All right, so this right here, I tried to put the bushing in and it wouldn't fit. It's like oblong. So if you've ever run into that, what you do is take a screwdriver and round it out. Careful not to go too big. There we go, good to go. We're just about to fit the head pressure control valve in. I had to put the bushing on. Yeah, we're doing good. Got some of the wet rag heat blocking compound packed around that valve, so that way it tries to protect it from overheating. But remember, I've said it many times, you need to get that stuff off ASAP because the moisture in the compound helps to absorb the heat and displace it temporarily. But eventually when that moisture starts to evaporate, the heat is gonna transfer through into the valve. So when you're done brazing, kick that stuff off ASAP with something because it's gonna be hot. That way you protect the valve more. Hold on. I'll tell you what. Yeah, it's good there. Yeah, use the wrench and give it a tap down low. Hold on. Let me see that. back them up because the lines will twist. You'll break something. So that's one. We'll have to do something to make sure it doesn't rub on the discharge line. We'll figure that out. So you always back it up. That way you don't twist the fitting off. Use leverage to help you. Okay, what I need you to do is hold this so it doesn't turn. There you go. We're going to get in here and change the dryer. I just got to kind of go for it. So we're going to get the old dryer out. Should have gotten my bigger wrenches, but I'm stubborn and just using the small 6-inch ones. All right, so we're pulling an evacuation. Got the 10 CFM pump kicking butt right now. I just closed the gas ballast because we just came down to a deeper vacuum. We're at about 600 microns now. That's not a true micron reading because I'm actually pulling from the high side too. But I'm using Fieldpiece's new micron gauge, the MG44. Look at that display. Nice big display, battery level indicator. And then it's got features on it where it tells you how fast it's pulling down. You've got a menu, alarm feature over here. One little quirk that I really like about it, a little feature they have, is the coupler right here has Schrader core depressors on both sides. So that's kind of cool because sometimes you run into a situation where this won't fit and you got to use the other side. Kind of neat little feature. So anyways, as we're going with our evacuation right now, I'm going to pull an initial vacuum, but eventually I'm going to close off the high side and the liquid side and pull just from the suction, so that way we get a true reading on the micron gauge, okay? Because right now, that's a much lower reading than it actually is in the system because it's so close to the vacuum pump itself. So we're going to give it some time, clean up some of our messes. We got to clean off the wet rag compound and just kind of overall clean up our job site because we got a lot of stuff. And then we'll go from there. We got down to about 600 microns and I closed off, I backseated this valve and the liquid line port, and it is inevitable that it's slowly gonna rise. It rose up a little bit, but now it's a true vacuum because it's not pulling from here anymore and it's only pulling from the suction side and it's going all the way through the system, okay? And you see we're slowly dropping. So that's a really good sign. It's always important to understand the evacuation and how it works and how a true vacuum works versus getting the, affected by the pump's pull in a negative way, I should say. All right, we're doing good. Cool thing I wanted to point out too is the micron gauge works with the Fieldpiece app. So right now it's in the sun, it's kind of hard to see, but I can pull it up on the app and you can set everything within the app. You can log it, you can set all the fun stuff in there. So cool within the Fieldpiece app, that works perfect. Our evacuation is looking good. We're actually in decay right now and we're rising slowly. We're at 648 right now. So nice and good. I'm pulling an evacuation on the gauges before we hook them up to the system or before we open the system to get them pulled down so that way we're not opening air into the system basically. But yeah, we're doing good. Our decay is looking good. It's always important to understand you're never going to hit a perfect vacuum on an old system. Old systems, they have refrigerant in the oil, little pockets everywhere, and it's never going to be a perfect vacuum, so always understand that. You always want to try your hardest to get the best vacuum, but you also got to be practical. Some things you can do to speed the evacuation up the entire time is agitate the compressor, shake it, turn on the crankcase heater, which mine's on right now. I have the system energized, solenoid valves open, and I have the compressor plug disconnected. So, but yeah, we're doing good. It's just slowly rising in decay, 662. So I'm happy with that. And we're just pulling this guy down before we open it up to, to the system and start charging it.
All right, we are running. This guy's back on and running. We're gonna go ahead and finish charging all the refrigerant. Now I flipped over the cylinder and hooked up to the vapor port just to make the charging process go faster. So, just so we weren't going through that dip tube. But we're gonna go ahead and put all the gas that was in here, and then we gotta pump it down and check the liquid level in the receiver. All right, so we got our valve right here, and we're gonna go ahead and pull it apart and see what caused it to stick. My opinion on these valves is it's usually user error, system error. It's not the valve that failed. It's something that got stuck in the valve. So let's go ahead and actually put the wrenches on there the right way. There we go. And there we go. Okay. Yeah, we're gonna very carefully try to pull this guy open. See what is in there. Okay, look at all that. That gunk is stuck in there. This valve is trashed. Look at the seat on that. It's got gunk in there. There's like nastiness, oil, sludge. There it is right there. Can you see inside there? There's a piece of something stuck in there. That is our problem. Can you see that? That little chunk right there is what was causing that thing to bypass. So that little piece on my finger is what was stuck. And you can actually see the mark right here where it's shiny on the seat. That piece was stuck there, allowing the gas to bypass inside the head pressure control valve. So it wasn't a failure of the valve. It was contaminants in the system. Now that, I'm interested to know what that is. I don't know if that's something from the compressor, because that's pretty hard metal. So there was something floating around in there for sure. Caused some damage. Our system is pumped down, and we went ahead and took a heat producing device and we heated up the side of the receiver. Now my paint marker went a little crazy, but that line up top is the liquid level. So the liquid level's at the 3/4 mark. We can't put any more refrigerant in this system. That's the maximum amount. We didn't add any, that's what we took out. So the system has the maximum amount of refrigerant in it. So at this point, we're gonna go ahead and clean up all of our tools and then do a thorough cleaning on this condenser because it's dirty. Well, I was able to kind of get into this condenser back in here, and I'm gonna get some coil cleaner, kind of spray it from this side out. It's not gonna be perfect. It's not too thick, so I'll be honest, I probably don't need to do a whole lot from in here. I might just rinse it from in here. Because again, it's only this thick. I think we can get right through that, no problem. As long as the water's going through, but we'll have to see if it actually goes all the way through. I think it is. Yeah. But it's always best to try to get it from the inside out if you can. So we're using the Venom Pack brightener. I'm gonna get in here and go to town. So I'm on like the second to least amount of concentration basically. So we're gonna get it all on there, let it sit. This is the brightener, so you got to be careful about leaving it on too long. But we're gonna let it sit on there, break everything down, and then we'll give it a good rinse. And let's see what we can get out of this bad boy. Coming out nice and good. I can hear it going right through the other side, so it's nice and clean. Some good stuff coming out the bottom, so we're gonna be good to go. All right, we're all cleaned up. I had ramped both of these thermostats down really low, so the way they do it, one of these fan motors runs 24/7, the other two are staged on temperature controllers, and I have it set for 80 and 85. Set all the defrost plugs, everything else is put back in, so we're just slowly wrapping this one up. The box, I went down there a few minutes ago, the box was at 50 degrees and they had just gotten a food delivery. So that's why we've only been up here for like 3 hours or so, but the box temp came up way high, but it's because they got a delivery and they left the door open and all that stuff. So, but yeah, should be doing good. Head pressure, yeah, looking good. I just got a wet condenser right now too though, but we're getting there. Okay, we're gonna autopsy this little guy. So we're gonna pour out the oil first. See how much is in it. So far, just letting the oil pour out. We're gonna try to figure out why this guy failed. It's been long enough that I can honestly tell you I don't remember what happened to it. You guys are watching the video, so you guys have already seen what happened to it. I'm trying to remember. I don't know if it was a starting component failure or a locked rotor amps. It's been a long couple weeks, so I've been sitting on this video for a while. So there's some oil, not a lot of oil though. Well, we're gonna keep letting it drain and then we'll see what comes of it. Okay, the oil doesn't look bad, but there's also not a lot of it in there. So I don't see too many rust flakes or anything. I mean, you know, metal shavings or anything in it yet, but we'll go ahead and open this guy up. We'll give it a cut. So the easiest way on these guys, each one of these little dimples right here is what's holding part of the scroll together. It actually sits inside in there and holds the mechanism in place. So we're gonna cut around the top, we're gonna cut down the seam, then we'll cut around the bottom, and we'll separate the scroll assembly. Every time I cut one of these open and I get to pull the head off, I think of the movie Hannibal, when he pulls the dude's head off when the dude's still alive. Now when I do this, you want to try to be as careful as possible to not get the metal shavings inside. It's inevitable that you're going to get some in there, but okay, we've got the top off now. Now we've got to cut down the seam, the weld right here. So we're going to cut straight down this weld, and then we'll probably have to flip it over and cut the bottom off too. All right, we got the shell cut open. Now you see the fusite plug right on the back side is just another plug, and then on that it looks just like a standard compressor plug. Okay, so we've got this guy opened up now. We're going to disassemble it, get it separated. You can see these little dimples right here. See those? Those are them right there, and they actually set in the housing right here and hold this in. Okay, so we're going to keep on going through this guy now. Little round dimples inside this. There's scarring on the top of the scroll plate. That's very interesting. I don't know if you guys can see it very well, but it's like round scarring in there. And same thing in here. Look at this. Huh. That's very interesting. There's plenty of oil in here, so I don't think it was a lack of oil. Huh. Wow, look at that, man. That is some serious scarring to the surface there. Very interesting. Huh. Very interesting. When it comes to these guys, I like saving the parts just for demonstration purposes later. So what I'll do is take some of the multi-purpose cleaner from Refrigeration Technologies, put it in a bucket, and it works as a good degreaser. Let it sit in there for about a day or two, and then once you pull the parts out, rinse them immediately and dry them off, and you'll have nice, good, clean scroll compressor parts, and it'll help to break down all the grease and oils and everything. So we're going to set all the parts in the bucket, fill it up with water, degrease it, and I'll use this for demonstration purposes later. This is a nice one because it's a really small one and it's not too heavy. All right, there was clearly something making its way through the system. That compressor, to me, looked like it had been pounding on something. The whole scroll plate was completely polished. Like something abrasive, something was moving through there. And then the head pressure control valve that had something stuck in it. I can't tell you how many people I see on social media message me, comment on my YouTube videos of how they hate head pressure control valves and how they always fail. In my opinion, head pressure control valves don't fail on their own. Just like a compressor, they're typically murdered, okay? The amount of head pressure control valves that actually have a failure that is just a valve that's worn out or something like that, in my opinion, is very, very rare. Majority of the time, it's improper refrigeration practices and or some sort of component in the system that is broken. Now, on the flip side, hey, maybe we should put some kind of a strainer, like or even some sort of a filter dryer or something like that. That's not a bad idea, installing a filter dryer before the head pressure control valve to catch anything from going into it. You know, because majority of the time, I've honestly never really thought about that. But now that I do, majority of the time, the head pressure control valve has failed that I've seen it has been something contaminating the inside of it. you know? So if we put some sort of a filter or a strainer, something that's removable, I'd like to be a flare or something like that, that, you know, we can pop out, ball valve it off and clean the dryer or something like that. That would potentially prevent whatever was stuck inside that valve. And I can't help but wonder if what was stuck inside that valve had made its way through the compressor too. I know it's almost impossible for something to make its way all the way up into that scroll assembly, but I mean, obviously it did, because it made it out of the discharge line into the head pressure control valve. And it was clearly a piece of something. Had this thing had a reciprocating compressor, honestly, it looked like a piece of a reed from a valve plate is what it looked like. Okay. So this was a frustrating call because, you know, of course you heard me saying, please don't be a compressor. Please don't be a compressor. This was late in the evening, right? Or late afternoon that I got this call. And then clearly it led into the evening because I was changing the compressor. Now, I used some shortcuts, but, you know, I was still being smart about it. I didn't change the dryer the night that I changed the compressor because I knew I was coming back to change that pressure control hose and the head pressure control valve. So there's no point in wasting my time trying to change the dryer the night before. You know, yeah, it was a flare, but still, I just wanted to go home, and there's nothing wrong with that, okay? And then also the way that I changed the compressor, I valved it off and just recovered the charge in the compressor shell, then swapped out the compressor. If you look at the systems, depending on the setup, you know, you can do that, and it could save you some time, okay? So we got the system operational. Clearly though, right, I've said before, if you choose to take shortcuts, sometimes there can be repercussions, and be prepared to have to solve those repercussions, right? In my situation, I took a shortcut and didn't protect the low pressure control hose, and it melted off, okay? Honestly, one of the reasons why I don't like those flexible hoses is because they're susceptible to that kind of damage. But on the flip side, a capillary tube hose can break too if it rubs up against something. But if a capillary tube hose is properly installed, you're never going to get it melting off, and it's never going to rub up against something if you secure it appropriately, putting silicone on it, that kind of stuff, okay? But anyways, I went back to the pressure control hose, put that back on. You know, I ran into some struggles. I tried to leave those struggles in the video, like when I was brazing in the head pressure control valve. I was having some issues with it getting to fit back in. You know, this kind of stuff happens, and you saw how difficult it was. I had to climb head first in there to change the dryer. This stuff is real, okay? These are the things that I run into all the time, and a lot of you guys probably run into those things too. And I feel like we need to show this more, because so many people see this and they think, oh, this is the easiest job in the world. While this is a fun job and it's a very rewarding job and it's a very technical job, sometimes you do run into difficulties and frustrations, you know? Changing a compressor at nighttime, getting home at 9, 10 o'clock at night, okay? For you supermarket guys, I know you guys deal with this stuff all the time, but us light commercial guys, you know, I mean, this is frustrating when we have to do these emergency calls. I would say that I get calls like this maybe once a month, maybe once every other month. I get a late night call where I have to change a compressor or something like that. It does happen, okay? So really important, when you are on call, you need to be prepared, okay? Remember that when you are on call, don't drink. You know, don't do things that's going to impair your ability. Be careful about taking medications and things like that, because you will get those calls, and they do come in at 2 in the morning, 3 in the morning. It happens, okay? So, I like to autopsy the compressors. Honestly, though, when I pulled this one apart, I could see there was damage, but it's interesting, though, because when this thing was trying to run, you know, when I was diagnosing it, the damage that I saw to the compressor, I haven't quite connected that to the failure. The failure of the compressor was the motor was running, but it wasn't pumping. I didn't see a broken shaft or anything like that. I mean, the motor seemed fine. The motor still had the proper resistance value. Everything seemed good with it. There was no damage to the bearing surfaces. There looked like there was oil in the system. While it looked a little bit low, the parts were all lubricated properly inside the system. And, you know, there was enough oil that the natural oil... it's not an oil pump. It's actually on the bottom of the shaft that it grabs it. I mean, it seemed like that would be pulling the oil up into the compressor. But it was interesting how polished those surfaces were on the scroll plate. So that's definitely an issue. What I'm actually going to do is I'm actually going to send this, I'm going to message my buddy Trevor Matthews with Emerson and ask him to look at the damage, and you know, I'll give him some points and see what he has to say about it and what he thinks happened, because this is an interesting one to me. You know, I'll be honest, majority of the scroll failures I see are either a grounded scroll or I've seen mechanical failure inside the scroll. I think I've autopsied a video showing that one. And then also I've seen, what's the other failure? Oh, the pressure relief device has failed, being that it's gone off so many times, you know, the differential pressure relief valve. I've seen that fail to where it won't pump anymore, you know, but I've never seen this failure where we had a locked up compressor, but then when I opened it up, or it wasn't locked up, where we had a compressor where the motor was running, but it wasn't pumping. And another thing too, just to, I don't think I showed it in the video enough. This compressor was not hot when I arrived. So it's not like it was off on a thermal overload or anything like that. And you could clearly see that it just wasn't pumping. There was something going on inside that compressor. It's an interesting one. Okay. Yeah, I think that's pretty much everything that I wanted to cover. I do want to say thank you guys so very much for making it to the end of this video. You guys are awesome. If you haven't already, please check out my website, hvacrvideos.com. It's a great way to support the channel. I've got hats, shirts, beanies, all that good stuff. It's just a cool way that you can support it and get something in return. Other ways to support the channel is through Patreon. There's links in the show notes of this video, through PayPal, through YouTube channel memberships. But the easiest way, guys, to support the channel is simply watch the video from start to end without skipping through anything, okay? When you do that, YouTube runs the ads, obviously, and then YouTube pays me. And it's just a cool way to help. Because, you know, I do spend a lot of time on these videos. Of course, I'm still going to make them, you know, whether you support them or not, because I do like to share this information. But it definitely helps to have, you know, something to help me out, because I put in hours and hours on these videos, you know, editing them and, you know, responding to emails and live streams and all that good stuff. But anyways, we're enough talking about that. Really, really appreciate you guys. Remember that I do live streams on Monday evening, 5 p.m. Pacific time, work permitting, obviously, if I can get off work in time, where I just kind of answer the questions and talk. And, you know, just if you haven't seen a live stream, come check it out. The live chat's always asking questions. We're interacting. We're talking. Also go live on the HVAC Overtime channel with my buddies, Adam, Joe, and Bill. And we, you know, just kind of recap the week. That's Friday evenings, about 6:05 p.m. Pacific. It happens every week, again, work permitting. Yeah, it's just another good way to get a hold of me, interact with me and my buddies. So definitely check it out, okay? You guys are amazing. Be kind to one another, and we will catch you on the next one, okay?